Hello and welcome to today's video. Today we will solve a Leetcode problem to implement a sequentially ordinal rank tracker. So in this problem we have been asked to build a tracker which allows tracking the locations by their rank. This tracker should allow adding new scenic locations and querying the ith best location. The location with the highest score is considered a better location, and if two scores are equal, then the location with the lexicographically smaller name is considered better. Let's look at the example. So in this example, we are first adding a location with the score 2 and then with the score 3. Naturally, the location with the score 3 is the next best location. So when we do a get, it returns us the location with the name Brentford. Next one is Bradford. So if there was a call to get the next best location, it would return us Bradford. But instead it's calling another add and passing it an else location with the score 2 and then calling the get method. Notice that Alps, being lexicographically smaller than Bradford, has got a higher rank than Bradford, which means the order of elements would be Bradford, Alps, and Bradford. And because our next best location is at index 1, starting with 0, that means Alps is the next best location. So what has happened here is, because we added a new location with the highest score above the next best location, the next best location had to be moved one position up. If it was added below the next best location, then we would not need to do that. For example, the example adds a location called Åland with a score 2. Now this matches the score of Bradford. Bradford, being lexicographically smaller, is returned as the next best location. So to solve this problem, I'm going to firstly represent the location with a class. And I will have two fields, name and score. And next I'll initialize them in the constructor. The next thing that I need to think about is what sort of data structure to use. So one of the requirements is that we need to be able to keep the locations in a sorted order. So I'm going to use a tree set because it will let me do that, plus it will stop any duplicates from getting added. The one thing we need to note is that when we use a tree set, it will use the natural ordering of the elements to keep the set sorted. But we do not want to use that natural ordering, so we will define our own ordering. The contract of the compare to method is that if two objects we're comparing are the same, then we return a 0. If one is less than the other, we return a negative, else positive. So if the scores don't match, we'll return the difference. I'm doing the difference by subtracting score from the other object score, because I want to store the value with the highest score at the top. And if the scores do match, then we'll compare the names. Let's now define the tree set. I will also define location object which will point to the next best location, and it will be updated every time I add a new location or get the next best location. Note that I'm not initializing to any value, so it will be null by default. So when my add method is called, I'll create a new location object and firstly add it to the locations collection. And we need to check that next best is not null before we compare it with the new location. Now if next best location is not null, then we need to check if the new location has got a higher score than the next best. And if it does, then we move next best one place up. So in this line, I'm essentially grabbing the element above the next best element by calling the method lower on the tree set. As you can see, I'm simply checking that the one above next best is not null before assigning it to the next best. Now, next thing we need to implement is what if the next best was null. So there are a couple of scenarios when this will happen. One is when the first element is added to the collection, and it can also happen if we have returned all the elements through the call to get. That means the next best was actually now pointing to a null. If that's the case, we need to assign the last element in the collection to the next best. The last method will return the last element in the collection and assign it to next best. This will make sure that next best is not pointing to null. The next thing we want to do is implement the get method. An important thing to note is once we return the next best element for the ith best element, we want to point to the next element in the collection. So firstly, let's keep a copy of the name of the next best element. And then let's move the next best to the one down in the set. The method higher will give us the next element after the element passed in as a parameter. And then we simply return the name we had copied earlier. Let's give this a run and submit. And thank you very much for watching. If you like this video, please consider liking and subscribing, and see you in the next video.